In this webcast, we're just going to create a very simple JSON API in CFWheels 2. To start with, all I've got is an incredibly simple app with a single user model, and I've pre-populated a database with some dummy data. So basically, I've just got a user model with first name, last name, email, etc. I haven't set up any routing, I haven't set up any controllers or anything like that. So the first thing I'm going to do is set up some routes. So by default, I'm not going to get much here. So what I want to do is set up the routes in a taffy style manner. So I'm going to add a namespace and I'm going to call it API. And within that, I'm going to have a version number, because with taffy, the way it sort of worked is you would copy all your controllers and all your version specific code into different folders with the version number in them. So we're going to sort of replicate that. And the other thing I'm going to do is put a resources helper called users. So that's pretty much my routes. So let's just check those first and just see whether they make sense or not. So here's my route list. I've got a fairly sensible URL pattern of API / the version number and then the resource. And I can also access all these routes with either a parameter or format equals whatever, or just users.json or whatever I want to do. So now I've got my route set up, I need to replicate this namespace structure in my controllers. So I'm just going to create a new folder. I'm going to call that API. And within that, I'm going to have another new folder, and it's going to be called v1. And then within that, I'm going to have a new file, and that's going to be users.cfc. So we're just going to build everything into this users.cfc file for now, just for ease. So the first thing we're going to need is to just set up some defaults. So what I've done here is I've got a component which extends app.controllers.controller. So app is the new CFWheels 2 mapping to the web route, and then obviously we're doing dot notation, so we're going into the controllers folder, and then we're extending the main controller. There's a default config function here, and index is just going to be our test function for now. So step one is going to be setting up this controller to provide a standard JSON response, and also only ever respond in JSON. So the first thing we're going to do is set up a filter function, and we're going to call this filters through, and we're going to call prep JSON response. And then down here we're going to add a new private function because we don't want this to be generally accessible. And within that function, we're going to set up a basic structure, which is what we're always going to use when we're responding with JSON. So we're going to call it RSESP, so shorthand for response. And then we're going to, within that structure, we're going to have a few others. So we'll probably have something like status, and we'll default that to a 200 response. And then we could do something like meta. There might be sort of pagination data or something like that, and there might be some actual data. So we'll have another structure there. The other thing we're going to do in this filter function is force it to always return JSON. So we're going to do params.format equals JSON. And basically what we're doing is we're overriding it and setting this on every response. The other thing we need to do is tell this controller to provide JSON rather than HTML. So in the top here, we're going to do provides JSON. Before we try and test this, we do need to do one last step, which is to tell the index page to actually render with our custom data. So in index, we're going to do renderWith, and we're going to just pass in the response object, which we created in our filter. So if we have a look at that in the browser, I'm going to go to API version 1 users, and I'm going to reload the app as well. There we get our bog standard JSON object. It might be that we want these responses to return a different status code. Thankfully, renderWith gives us a really easy way of doing this. First thing to do is to start using named arguments in renderWith. So we're going to call this one data. So data is basically the actual body of the request. And then what we can do is we can pass in a custom status code just by using status. So we could do 403 here, or we could do something like we could actually use the status that we've set in the defaults. So this, if we look back in the browser, responds with the 200. But if we go back and change the default status code to something like 403, because it might be that you need authentication, and we reload, we now get a 403 forbidden status. So that's good. That's what we want. So at this point, I probably want to start adding some data. So I probably would switch over to something like Postman for testing the actual responses. If you've not used Postman before, it's free and it's available for Windows and Mac. And we'll have a look at that now. So I've booted up Postman, and the first thing I'm going to do is add an environment. So this will allow me to add some variables so I can just very quickly create requests. So I'm going to give it a name. I'm just going to call this local, and I'm going to call this key something like API root. And in there, I can chuck in the base URL for the API that I'm creating. So let's add that. Oops. And now I switch the environment from this drop down to local, and I can then start throwing out requests. So in here, I can now use my API root from the environment, and I can do /users. And well, let's give that a go. Okay, so I've got a sort of pretty print formatted version here, the raw thing here, and it was an HTML preview. So most of the time we'll just be on here. What's particularly nice about this is you can start doing things like inspecting the cookies. You can look at all the headers which are coming through, and you can even actually set up some very rudimentary tests, like, well, not actually that rudimentary, some quite clever tests. So for instance, you can check on the status, the response time, and once you've set these up for each response endpoint in your API, you can then just bulk run them like over time and test the response and the speed of the API. So it's actually a really useful tool. So next up, we actually now need to start actually returning some users. So let's just do a standard sort of model call. So we'll do users equals model user.findAll, and because I've got about 1,000 rows of data in here, I'm just going to do max rows equals 10 just so we can test it. Now I've got a query object here. So from this point, I can go one of 2 or 3 ways. I can either just return this directly in my renderWith call by setting it to response.data, or I could change this findAll call to return structs rather than a query object, or I could then take this user data and go over it manually and create my own struct. So let's just have a look at each way of doing this and how it differs in the response. So the first one I'm going to start with is just literally returning these users in the response.data bit. So if we do response.data, and we'll just set that as being the users. And if we go back to Postman and we rerun our request and we click send, we now get this well, somewhat ugly response. I don't actually like the way this default behavior. I don't like the fact that the column names come separately. I don't particularly like the fact the data rows, there are times when this is fine. It's not particularly my style. I don't particularly like it. So let's have a look at the other ways of doing this. The next way of doing this would just be to return the results of the findAll as structs rather than a query object. So we're just going to do return as structs. And let's rerun that in Postman. And to me, that makes a lot more sense. You get, a proper object, and that's much more usable in terms of front ends you might use it with, like React or Vue or whatever. The last option, if we want the maximum amount of control, is to create our own object, which we then just pass back. So let's create a new struct, and we're going to call it user response. And in fact, we're going to make that an array because we're just going to loop over it. So we're going to do for user in users. We're going to array append the users array, user response, and we're going to create a new struct here, and we're just, for speed, we're just going to pass in the user ID and the email. So now we just need to set the user response array to be part of the response object. Okay, so now let's give that a try. Great, that makes sense. And I've got, absolute full control of what's being returned to me here. So I tend to use this approach just because I really like seeing the fields, and I don't like relying on sort of the serialization, the built-in serialization. So I prefer this route. So the next step might be to see if we can add something like pagination to this. So let's set up some default parameters. We'll do params.page. So this is going to be the default page number. And then we're going to do the number of records we want to return in each page. So that's per page. And we're going to default this to 10. Now in our find all call, we can just do page equals params.page and per page equals params.perPage. So there's a nice little trick here where we can actually just get the pagination information automatically from Wheels. So what we can do is we can set our meta struct, so response.meta, just to pagination. And that will pull back everything from Wheels to do with that query. So let's have a look at that. And so now you can see we've got this nice little meta block with the total number of records, the current page, etc. And so we could actually just do, page equals 2 from this, and we're on page 2.